Hello everyone. Okay, so in this video, continuing on integration, we're now going to be looking at finding the area between two curves. So looking here, right, we have these two functions here, and we're asked to find this shaded blue region. Now, how on earth would we do this? Well, the first way we could do it is we could break it up, right? We could find the point of intersection here. We can find the point of intersection, ding, duong. And what I could do is I could find the area under the line. So here's the area under the line between them 2 points. Makes it a bit easier. So I can find the area underneath them 2 points here. And then, between them 2 points, I should say, and the line. And then, in order for me to get this kind of blue part here, I subtract then the area beneath my curve between them 2 points. So here's my curve here, right? Then I find the area between them two curves here, right, between them two values. And then I just subtract that area from that blue area, and that gives me then this area here. Now, there is an easier way of doing it, right? So, the integration between two curves, the area between two curves, f of x and g of x, is given by, so it's the integral of f of x between b and a minus the integral of g of x between b and a. So that's basically what I just said there. But also, this can be written as the integral between a and b of f of x minus g of x. So I subtract two functions first, then I integrate them. So I can do this. Why can I do this? So if I just go to the GeoGebra, let me just ding 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 set it up. Boom, right. So here's the GeoGebra. So what I could do here is, so say I have the x squared here, and then, actually let's say I have x squared minus 1, right? And then I just have the function x. So I'm asked to find now the area between these two curves. And you're probably wondering yourself, I was like, well, didn't you say in the last video, right, the area underneath the x-axis will be negative? And you are correct in saying that. I did say that, right? However, what if I now apply a translation to these two functions and like a vertical movement? And to do a vertical movement, right, we add a constant. So what I'm going to do here is I'm going to add a plus c to both of them. So I'm going to add a constant to both of these. So, right, if I add a constant to them, right, it should shift them up. Let me just see, plus c starting and plus c starting. Oh, not that one. There we go, right? So, looking here, right? So, this is what I was originally asked to find. And you're probably wondering, here, well, don't we have a little negative area here? Well, if I add a plus c, right, here, the same plus c to both functions, right, hypothetically speaking, I can move them both up above the x-axis, right? And what's so great about them is, if you look here at my function, so x squared minus 1 plus c and x plus c, right? When I integrate them, the c's are going to cancel out anyway. So that's why I actually don't have to worry about it. So just to kind of go, back here. So basically, I don't need to worry about negative area. So all I need to do is, area underneath an x-axis, I mean, it's just I take away the two functions and I integrate between them, and that's it. So to find the area between two curves, I first need to find the point of intersection of the two functions. And if the functions are written in the form f of x equals something and g of x equals something, you just let them equal each other. Bada boom, bada bing. Easy peasy, lemon squeezy. If they're not written like that, you need to rewrite them in the form y equals something, or f of x equals something, g of x equals something, etc., etc. Then the second step is you subtract the functions. Then you integrate them between the two x values I calculated in part 1. So calculate between the 2 points of intersection from part 1. If the area is negative, I just make it positive. And then if there's more than one shaded area, or more than one area I need to find, I need to do them separately. So let's have a look here. So by finding the areas above and below the x-axis, find the area bounded by the line f of x equals 2x, and the curve g of x equals x squared minus 2x. So step 1, find where the two functions are equal. So 2x equals x squared minus 2x. So they're both in the form f of x equals something and g of x equals something. So I can just let f of x equal g of x. Bring them all over to one side. X squared minus 4x, right, equals 0. Stunning. Now, I solve for x, factor out x. I'm going to have x minus 4 equals 0. I'm going to have x equals 0 and x equals 4. And that's all I need for the time being. So this is 0 and this is 4. So now I need to now integrate them, subtract the functions, and integrate between 4 and 0. So it's going to be x squared minus 4x. 4, 0, x cubed all over 3 minus 2x squared. That's going to be 4 cubed all over 3 minus 2 times 4 squared minus, now I sub in 0. Well, 0 cubed over 3 is just 0, and then minus 2 times 0 squared is just 0. So I'm going to be left with here 4 cubed divided by 3 minus 2 times 4 squared, which is going to be equal to minus 32 over 3. But again, we can't have negative area, so it's just going to be positive 32 over 3. And bada boom, bada bing, that is the area between two curves. This is an exam question here. So we're asked to find the shaded region here. So find the area of the shaded region diagram below, which represents the region between the graphs of x plus 4 and x squared minus 2, between the interval minus 1 and 2. So we are now looking for the integral from 2 to minus 1. And I'm going to subtract my function. So x squared minus 2 minus x plus 4. That's going to be the integral of 2 to minus 1 of x squared minus x minus 6. 2 minus 1 is going to be x cubed all over 3 minus x squared all over 2 minus 6x. So that is going to be 8 over 3 minus 2 squared all over 2 minus 6 times 2 minus negative 1 cubed all over 3 minus minus 1 squared all over 2 minus 6 times minus 1. And that is going to be ding, ding, ding. The answer here is going to be minus 33 over 2. But as I said, we can't have negative area. So the area is actually going to be 33 over 2 units squared. Okay, let's look at this one from 2024. The logo for a company shown below the logo is in the region enclosed by 3 curves defined by the following. C of x equals x squared, and s of x equals 2x minus x squared. K of x is the image of s of x under axial symmetry in the y-axis. Use integration to work out the area of the logo. So this is axial symmetry. So this area will be equal to this area. So if I find the area here, and I just double it. So I'm integrating between 0 and 1. S of x minus c of x, so it'll be 2x minus x squared minus x squared, which between 1 and 0, so 2x minus 2x squared, which is x squared minus 2x cubed all over 3. Integrate between 1 and 0. That's going to be 1 minus 2/3. Then sub in 0. I'm just going to get 0 minus 0. So my answer is 1/3, but that's just one area here. Therefore, times it by 2. So my answer is 2/3 units squared. Fine. Now here, 2018, find the coordinates of the point of intersection of these two graphs. So h of x equals x and k of x equals x cubed. So x equals x cubed, bring them all to one side. 0 equals x cubed minus x. Factor out an x. I'm going to be left with here. X bracket x squared minus 1. X times x plus 1. X minus 1. Therefore, x equals 0, x equals minus 1, x equals positive 1. And then the point of intersection then would be, to sub them back in, it should be 1, 1, 0, 0, and minus 1, minus 1. So this is minus 1, 0, 1. Find the total area enclosed by the two functions. So, as I said before, right, it's important when I'm doing this, right? When I'm doing this, I need to do it separately. Okay, so I need to do this separately first. So I'm going to find the integral between minus 1 and 0, and then find the integral between 0 and 1. So the integral between minus 1, 0 of x cubed minus x, so subtract the two functions, that is going to be the integral of x to the power of 4 all over 4 minus x squared all over 2, which is going to be equal to 0 minus a quarter minus a half. So the area of there would be minus a half. But like not minus a half, positive a half. You sub that in. But like I said, yeah. So that's the first area there. Now, there's a good chance this is also equal to a half, but we'll try it out anyway. I need to find the integral now between 1 and 0. So that is going to be, so x to the power of 4 all over 4 minus x squared all over 2. That's going to be 0 minus, then, because we're sub-zero in, they're all going to cancel out, minus a quarter minus a half, which is going to be equal to, I'm sorry, this is going to be a quarter. This is also going to be equal to a quarter. So therefore, the total area equals a half. A quarter plus a quarter is a half. A half units squared. Right. 2 more here. 2017, parts of the graph of the function shown below. F of x equals e to the x and g of x equals e to the minus x, along with the vertical line x equals 0.75. Find the total area enclosed in the graph. So it is, I'm looking for this here. So I'm looking for the area between e of x and e to the minus x between 0 and 0.75. So 0.75. E to the x minus e to the minus x, that is going to be e to the x plus e to the minus x, because I divided by minus 1, derivative of there. That is going to be equal to e to the 0.75 plus e to the minus 0.75, then minus sub in 0. So e to the power 0 plus e to the power 0, which is 1 plus 1, which is 2. So e to the power of 0.75 plus e to the power of minus 0.75 minus 2. And my answer here is going to be 0.5894. The 5894. Right, then last one here. 2012, the function f and g are defined. F of x equals 2x squared minus 3x plus 2, and g of x equals x squared plus x minus 7. Find the area enclosed in the graph. So again, I'm just looking for this area here. I don't have a domain, not a domain. I don't have an upper or lower bound, so I need to find the point of intersection first. So 2x squared minus 3x plus 2 equals x squared plus x plus 7. Bring everything over. X squared minus 4x minus 5 equals 0. X minus 5, x plus 1 equals 0. X is equal to 5 and x equals to minus 1. So there is my upper and lower bound. So I'm integrating between 5 and minus 1. And then x squared minus 4x minus 5. Integrating now between 5 and minus 1 of x cubed all over 3 minus 2x squared minus 5x. Then sub that in to our calculators there. So like I said, we could use, oops, Daisy. Like I said, we could use our calculators if we wished. So if I just open up this here. Right. There's my calculator here. Let me type in my function here. So my function, I'm just gonna go define my function, which is x cubed all over 3 minus 2x squared minus 5x. There's my function there. Then I am now doing so f of 5 minus f of negative 1. And my answer is minus 36. But again, we can't have negative area. So the answer is plus 36 units squared. And that is the area between them curves. Right, I hope this video was some help to you guys. And I'll catch you guys later. Bye.